All right, guys, welcome back. We are in day 2 of weather fronts. Go ahead and go to page 6 now, page 6, because page 5 was this right here, the weather fronts organizer that we set up from our last lesson, weather fronts 1. Go ahead and write down our Go Blue questions. And don't forget, we got the vocab due next Friday for my new students who joined the new class on Canvas. And for my normal students, it would be due this Friday when this is posted. So the questions include, number 1, what creates weather fronts? What makes a weather front? 2, how are warm and cold fronts different? And 3, list and identify fronts 1 through 5 here on the screen. We're not going to worry about 6, 7, 8, or 9, just 1 through 5 for our future quiz and test. Give you guys a second before we move on here. Okay, so let's go ahead. Again, if I go too fast, you guys feel free to pause the video as you watch. For our answers here, fronts are created by interaction between warm and cool air masses. Warm and cool air masses. So it's not directly beneath the air mass. It's right in between where we have, again, those storms, that precipitation, and all that stuff, right? Number 2, how are cool and warm fronts different? Warm fronts and cool fronts different, okay? Warm fronts are going to be where warm air replaces cold air. If you know one, you know the other. It's the opposite, right? We've just got moderate rainfall, just so you guys know here in the future. I said that a little bit in the video. Whereas cold fronts are going to be cool air replaces warm air, right? Cool air replaces warm air. But differently, this brings about severe storms and severe weather, okay? And then number 3, number 1 is going to be with the blue triangles, our cold front. 2 is going to be our warm front. 3 is going to be our stationary front. Again, we've got the red half circles and the blue triangles facing opposite directions. And then 4 is our occluded front, and 5 is our trough. We set that up on this page. Again, if you're confused, go back to weather fronts lesson, weather fronts 1. You're going to find all these for your answers. Okay. I think we just have one. We do have a new set of notes we'll be beginning the next lesson, which are wind systems. List that for page 6 and 7 wind systems. 6 and 7 wind systems. Again, we'll do a question here at the end when you guys are ready. And as for our video question of today on page 6, I just want you guys to write the question number 1. What process creates shelf clouds? What process creates shelf clouds? We'll show the video here in a second. I'll give you a hint. It has to do with our weather fronts. No need. We're not going to get to number 2. We're just going to skip number 2. Do not worry about number 2. Again, page 6. What process creates shelf clouds? Let's go again. I'm going to mute the video for obvious reasons, but let's check out what they see here. So you see this video here. We've got a shelf cloud. Oftentimes they look very ominous, like a massive storm is on its way, right? Okay, and again, I don't have the audio, just so you guys know, because YouTube will not let videos be posted of other videos if it's like too identical with it. Now, here's the radar. We'll know, again, the red is the more severe weather, with the green being the heavy rain. And then this blue band up front, again, usually blue represents snow, but in this case, it's going to be just the radar reading the clouds building up. This is the cloud buildup in front of the storm. Now, what does this look like if we get like an anatomy breakdown of it from the side? Okay, well, what you're going to see here is, again, we see just like our fronts, cool air against warm air. And as you can see, this is obviously a cold front because the cold air is pushing out the warm air. But what happens is this interaction happens where the cool air slightly starts to kind of slide beneath the warm air at the front. And this causes like a low curl of those clouds, which cause them to dip. That makes that shelf cloud, which looks very ominous. Now, behind that's all the rain, right? But in front of that is the ominous approaching clouds on their way, right? So that's going to be answering our question there. So let's go back to number 1. Our answer includes cool air gets under warm air and condenses it. So that warm air kind of collects together and it builds up that shelf cloud that faces the front of that storm. We call that a gust front. So make sure you write that answer down for number 1. Again, we call that a gust front. Let's go ahead and continue. We'll get to questions later. let's continue where we left off with weather fronts. Okay, for today, I'm just going to kind of go through these quickly. I've got a bunch of videos for them, but they're all like 45 seconds. So again, feel free to research those. You can look those up on YouTube and find those 1-minute videos, but otherwise the pictures kind of answers it for us anyway. We left off on cold fronts. Again, we need to be on page 5, where you see this sheet here. Okay. Again, we need to be on page 5. We've already filled out cold fronts. Now we're going to fill out warm front, stationary, occluded, and trough before we finish up with our last question of the day. So make sure we are on that as we move along. Okay. So warm fronts, guys. Again, it's just the opposite of a cold front, like we said in our Go Blue. Now warm air replaces cool air, and instead of severe storms, we've got moderate rainfall. Again, only write what's in red for these notes on page 5, a lot shorter than our air masses notes. I know we're all happy about that, right? Again, I don't have fill in the blanks because I know a lot of you don't have printers at home, so we'll do our best with that as we move forward. Again, warm air swooping and pushing the cool air out. And then for our stationary, this is a little bit more the most writing we'll see today. Again, we're now on the third section here, now it's not warm air winning or cool air winning the battle. Now you've got warm and cool air in a tie. You got warm and cool air pretty much in a tie. Okay, so keep that in mind. And with that being in a tie, basically it's not like severe rain. It's still a moderate rainfall like the warm front, but it's a very slow-moving storm. It's a slow-moving storm. So what do you get with that? You're going to get some flooding. Long-term rain could be an issue, right? So again, cool air with warm air, lighter heavy precipitation, slow-moving storm. It's going to cause, again, it's a tie, going to cause some flooding. Next, we have occluded front, this purple line with the circles and triangles, but now they're going in the same direction, okay? Maybe our second most severe of the 5, but cold is still the most severe. It's where the cold air just completely overtakes the warm air, right? Completely overtakes it. This is going to cause some heavy rain, but also some very high winds. So you're not going to see tornadoes, lightning, and hail, but you're going to get close to it, maybe close to that, okay? And our last one of the day right here, again, only write what's in red, is the trough at the bottom here, our trough line. That's going to be an elongated area of low pressure. And if you guys remember, low pressure, low lets clouds grow. Low clouds grow. With that, we're naturally going to get some just moderate, normal rainfall. But understand it's an area of low pressure. Now, why are we knowing all these symbols? Because like I've said before, guys, we need to know and be able to read a weather map that's just like the ones that meteorologists read. You're going to get a bunch of symbols on it, and there's going to be no words, and we're going to be able to read those symbols and know exactly what's going on with the weather in those areas. Let's go ahead and go to our last question of the day. And I'm going to go ahead and move this screen so that we don't see what I'm going to pull up here. Let's see. One second. Don't want to give away any answers if I pull up the question and it's not the right thing, right? Maybe we'll do, let's show this. Let's see if it's showing it. No, it's not. Okay, we're good. It still just says question. Gotta be a front question, am I right? Oh, you know what? This will be a good question. This is one we need to work on. Okay, so let's do this, the screen. All right. So we talked about air masses. So we've got to know, based on locations, what air mass most influences that area. Now, I've got a city called Calgary, Canada, up in central Canada. Two things you got to ask yourself. Is it closer to the pole or the equator, right? Equator's down here, pole's up here. And is it surrounded by land or next to water? Okay, that's what we need to think about. So with that being said, is it A, maritime tropical, B, maritime polar, C, continental tropical, or D, continental polar? If you're stuck, again, check page 3. You'll see the answer there regarding our combination list of what could be the most likely weather. Okay, pause the video, see what the answer is. It's going to be, oh, wrong thing. Going to be letter D, continental polar. Why? Surrounded by land, it's continental dry. Closer to the North Pole means it's polar. Equator's all the way down here, right? All right, again, guys, don't forget projects. Get started on those and vocabs. This is Mr. Campbell signing out.